Hello, my name is Didem, and this is my video demonstration for Practical Work 3. I will be demonstrating my work on Variation 19, which is the financial fraud analyst scenario for FinSecure Banking. And today I will explain what MongoDB is, show you how I use it for my project, and walk through my database structure, and also briefly demonstrate the data import process. What is MongoDB? MongoDB is a document-oriented NoSQL database, which means it stores data in a very different way compared to traditional relational databases, just like MySQL or PostgreSQL. Instead of storing data in tables with rows and columns, MongoDB uses documents that look similar to JSON objects. Each document can have its own structure and can contain nested data, which makes it really flexible. For example, a transaction document can have merchant information embedded directly inside it rather than requiring a separate table or joins. The main difference from relational databases is that MongoDB doesn't enforce a strict schema. You can add new fields to documents without having to modify table structures, and different documents in the same collection can have different fields. This flexibility is great for applications where data structures might evolve over time or where you need fast read performance for analytical queries. For this project, I installed MongoDB Community Server version 8.2 and MongoDB Compass on my Windows machine. I set up the environment by adding MongoDB to my system path so I could run commands from any terminal location. I use MongoDB Compass as my interface for importing data and visualizing the collections. I also use the MongoDB shell, which is accessible through Compass to write and execute all my scripts and queries. The connection string I used throughout the project was the default local connection. And now let me show you my database structure. So I created a database called FinanceDB with three main collections. First, we have the transactions collection. This contains all the individual transaction records. Each document has fields like transaction ID, the amount of money involved, and a timestamp showing when it happened. Also, IDs linking to the account and merchant. Second is accounts collection. This stores customer account information, including account limits and current balances. And this helps track spending patterns and identify when accounts might be exceeding their limits. Also, third is the merchants collection, which is reference data about the businesses where transactions occur. Each merchant has a name, category like electronics and travel, the city they're in, and a risk score that indicates how risky transactions at that merchant might be. And also, I created a fourth collection called Transactions Enhanced. This is a denormalized version where I combine transactions and merchant data together for faster queries. And now I will demonstrate the query 5.2, which is high risk alert. The title is Flag Severe Security Threats. The purpose of this is to identify transactions with risk exposure, and the business value is that it enables rapid response to potentially fraudulent high-value transactions. In stage one, we filter high-risk transactions, so we find transactions where risk exposure exceeds the 750,000 threshold. Stage two is the selecting relevant fields for alert, which displays only essential information for security team. Here's the code, and first line excludes MongoDB's default ID, then rename ID to transaction ID for clarity. Then extract merchant name from embedded documents, and then include calculated risk exposure value. For stage three, it shows highest risks first. It prioritizes most dangerous transactions for immediate investigation. And for stage four, it returns top 5 alerts. The purpose of is to focus on most critical cases. And lastly, it displays results in JSON format for instructor verification. And also, this is how I imported my JSON files. And as a conclusion, MongoDB is a document-oriented database that stores data in flexible JSON-like structures. I use it to build fraud detection system by importing transaction, account, merchant data, fixing data type issues, creating a denormalized collection for fast queries, and writing aggregation pipelines to identify patterns and risks. The key advantage of MongoDB for this use case is its query performance. By embedding related data together and avoiding joins, we can run complex analytical queries very quickly, which is exactly what you need for real-time fraud detection. And that is all. Thank you for watching.